Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12. Build your understanding question number 8. A particle of mass m and charge q projected with a speed u at an angle theta above the horizontal. After traveling a horizontal distance x0, the particle enters a region where, in addition to gravity, a uniform static horizontal electric field also exists. Boundary of this region is vertical. If after some time the particle returns to the point of projection, find magnitude of the electric field and the time of flight of the particle. Acceleration of free fall is g and influence of the air is to be neglected. Let us solve this question. Collected all the data here. Particle is having mass m and charge q on it. Particle projected with initial velocity u at an angle theta from the horizontal. After traveling a horizontal distance x0, it enters in an horizontal electric field, let's say E. So this x0, and from here the electric field starts. After some time, particle returns to its projection point P. Again the same point. Acceleration of free fall is given g and air resistance to neglect. There is no change in force in the y direction throughout its motion, because in the question it is giving E field is in the horizontal direction. We have taken y and x as y is what this side and x is on this side. Since no change in force in the y direction throughout its motion, and it is only the gravitational pull which is acting on the particle, therefore the time of flight will be equal to the time particle will take to reach to its maximum height and comes back to the same height from where it was projected, because in the question it is given the particle finally returns back to the point from where it was projected. So we can conveniently write the equation of motion for the projectile as this. Distance cover. The displacement is 0 because particle went up under the influence of g, the gravitational pull, and it comes back. So displacement is 0, so we have put 0. Initial velocity in the y direction was u sine theta, because theta is this. So in the from y direction, the u will make an angle 90 minus theta, so u sine theta. T we have taken as the time of flight, like from the time it was projected and coming back to the point P. So u sine theta into t minus half gt square, you can write this equation. So t will be 2u sine theta by g. So therefore time of flight will not change. and its value, time of flight of the particle, will be 2u sine theta by g. So this will be our one of the answer for this part. Now we are to find E is what? So till t is equal to t naught, means time counting we have started from point P. So t was 0 at this point. From there to here it took time t naught. So the velocity, so till t is equal to t naught, the component of velocity in the x direction, that is u cos theta, will remain same as there is no force acting in the horizontal direction till point A. So we can calculate this time t naught. So that will be u cos theta into t naught, that is equal to this distance. So t naught will be x naught by u cos theta. This is our equation number 2. After A, the particle enters into the electric field region. So when the particle enters in static horizontal E field at axis A prime, it starts experiencing a force in the horizontal direction. In question, it is given that particle finally is reaching to its projection point P. What does it mean? It means the horizontal force should reverse the motion in the horizontal direction to enable the particle comes back to the projection point. Therefore, the E field direction will be as shown in this diagram in figure 1. So once the particle enters into the E field, it will start slowing down because the force is acting opposite to the motion in the horizontal direction. So we can write this equation from the equation of motion. Final velocity is 0, initial velocity is u cos theta, minus sign has come for the acceleration because it is decelerating. Acceleration is force is acting opposite to the motion, into t1 minus t naught. T1 is the time from 0 to reach till B point. So therefore, this between the A point and B point, the time spent was T1 minus T naught. You can refer the diagram. So we will get T1 minus T naught as u cos theta by A. This will be your number 3 question. Now we know the force. Force is electrostatic force in the horizontal direction. That will be equal to the charge on the particles into the electric field intensity, that is E, and divided by its mass. So we will get the acceleration. This we say it as equation 4. This we will later use in equation 3 to get T1 minus T2. After that, the particle will start gaining the velocity. Means particle first it will come to stop, and then it will start gaining the velocity because the direction of the direction of motion of the particle reverse from there under the influence of the electrostatic force, and will start moving in the reverse direction. Acceleration A in the electric field will remain the same throughout because the force is constant and mass also is constant. So A will remain same throughout in the field on the particle. Initially, it will work against the motion, and after stop, A will work in favor of the motion. Means acceleration will be when the particle start moving in the direction of the force, it will favor. The particle when just leaves the E field will gain the velocity u cos theta towards the projection point. Because the force is same, acceleration will be same, and the time elapsed will be same to reach from B to A while coming back towards the projection point. Since the acceleration is same in the horizontal direction, it will take the same time t1 minus t0 to reach the point A. Okay. So the remaining time to reach the projection point will be the total time of the flight minus t0 is the time from the projection point to reach an x0 displacement in the horizontal direction, plus 2 into, because 2 times in the electric field the particle travels, one in going, one in coming. The time is same, the time duration is same. So 2 times t1 minus t0. So we will use the equations and the value which has been derived earlier, and we will put the value in this equation. Putting the value of t and t1 minus t0, we will be getting this. Upon solving, we will be getting A is equal to A this much u square cos square theta z divided by u square cos theta into sin theta minus x naught g. A from equation 4 we will put the value q e by m. So E we will be getting as this much mg by q into u square cos square theta in numerator, in denominator, in bracket u square cos theta into sin theta minus x naught into g, bracket close. So this will be the answer for your E field. Time of flight already we have derived earlier. So both the answers are with us. So hopefully you understood the concept. In case of any doubt, please write in the comment box. I will clarify. And please go through the write-up carefully so that it will give you ease in understanding. Thank you.